All right, and here we go. Hello. Today is the first day after the release of this first stage of the rig. Finally, after a lot of battling this thing and pandemic stuff. So for everyone that we're basically together in this thing. So I hope you're all good, and not only in health, but I hope we all get through this fast as possible. And yeah, it was just trying to get that mornings, but morning meaning like midnight to 4 a.m. or something like that. And here we are after that I made what was possible to publish on the weekend. And now we're back to the development, get the intro cam going on here. And my image has gone away for some reason, but anyways, so I'm opening up the rig here right now, and let's see if I can get the camera just slightly bit to the side. And this is what we get with the rig as it was animated. It's not that long of an animation anyways. It's a 25 frame animation. I turn off the volume here so that we can just check out the animation without even the textures for now. Let's see if I can push it back here into, I think it was 220 or something like that. Nope. I'm hitting space bar like if it was a player. If you cross a mentally ill lunar with the society, blah, blah, blah. That's mostly what he's saying here. So yeah, today I'll be focusing on something else, not so I need to get the next system done. Be somewhere around here. I'll definitely mouth template that should be. Yeah, so basically this is the joint systems or the joint templates we have in place. The ones that we're aiming for is next. So it's seven locators here that we're used to. Let me see if I can come into the front camera here. Front monitor. Now it's better. So basically we have the 7 joints, and I need to script the system to make this a working neck. This is based on the skeleton that we also have in place here. And yeah, this guy's locked up, I don't know, for some reason, but so each joint there should represent a vertebra on the spine. So there's 7 of them, and after that I'll be able to get closer into automating the mouth system. And let's try to go up all the way into the eye. So every time I'll try to automate a little more. This is what we have right now. I have just a so what I have here is a broad with working with object-oriented programming, and it's good. I'll probably be doing this anyway, but right module and this function should get only the information that it needs. So I'll jump in right away into the function, and so this way I can keep my focus on the work and nothing else. So I'll keep my Maya open here, and Maybe you can see hook in here every once in a while. I'm using PyCharm here. If you don't know anything about scripting, PyCharm is just a script editor. So here I'm going to start by defining a function, which I'm sure if I can see. Let me see if I can get a list as an input here. Be like joint list. That I'll be doing anyways, which is just researching. So function, so Python function pass list. Yeah, so the argument here. So apparently I don't need to define that this is a list, which is fine for me. So what I'm going to do then is, to be honest, the best thing I could do here is just have critical. Okay, so first of all, what we're going to do is check how the curve. So this is mostly how any coding process starts for me. Like I will first check how the system is doing what it's doing, right? So a good way to do it is, let's get here and go into create. I want to create a curve. It'll be a curves tool. And we're going to define, so here we have a one linear. In this case I want a three cubic, and what I want is to hold V and click on this guys here, and then hit enter. It's going to create the curve. Then we have the curve here on the bottom. Right, so this is what I need the script to do. So you can see here that what it did in order to create this is basically it used the data that I stored there, like by selecting the points there. This is what, so yeah, it is formatting. If I can, I forgot how to be paste without formatting. Okay, so this is what we can see here. Let's comment this just not to get all this complaining about whatever. It doesn't like the fact that we're going through that line. That's fine as well. So you can see that the only thing here is like D, which is the 3 cubic thing that we've chosen, and then we have the points, right? We have P. It's all good. Doesn't seem to be too complex, and then you have the K's here. For each point, the system is calling this flag and then declaring the the position of these 3 variables in space. Okay. So then first of all, I'm going to check out for the search looking at. So you can see that the way it calls it here, then it's not the way it's calling the, could be a list, it just could be just a normal list anyways. So you have p, which is point, and you have point weight, right? So I don't know what the point weight thing is, and the not, it's something that I don't really get, and like something that they at the end it always uses this not here with a bunch of values for the knots, but I don't get it, and every time I do it without it, it doesn't even care. So I'm assuming we have this joint list here, right? So what we are going to do is create a position, or better yet, points list, points list, and this is just declaring a variable here. Oh god, seriously. All right, so then with this we're gonna go and create a, so I'll try first the first thing that comes to my mind, and then we're gonna progressing around that, right? So another way of seeing this, so I need to get the point, the locator. I'm gonna call it locator position into list, right? So this is like a joint list, could be like let's call it pointer list. I think this is a better naming, because this is what I'm calling a joint, but it's really a pointer, I call it is a template pointer. So from this pointer here I can get whatever information I need. So get position, get pointers position into list, and then with that I can draw curve from pointers, right? Then after, so this is going to be this guy here, and I can even get rid of this, I guess. So then we need to do is offset curve position, and then what I need to do is, because I need this curve then to go this side and another one to go this side here, so that we can create a surface, right? So also I need to bind joint for each pointer. So for each one of these pointers here, we need a actual joint. This is a joint right now, but again, it's just a location point or data pointer that holds a lot of information. We have this metadata here stored on it. Where is it? Should have its extra attributes. Yeah, have this metadata here stored with a bunch of information about this position and where it belongs to, whatever. Again, it's me thinking on the fly. Here's me checking Facebook. Answering us for each pointer, also create a driver joint for each cluster or for each pointer. Click duplicate curve. This is the series of actions that we need in order to create the system, but still uses the same way of thinking. And for any of you like software engineers, please forgive my ingenuity here, my naiveness. All right, so we're going to offset, so duplicate the curve, offset curves position, and then we're going to loft curves, clear history, okay, so now we have, then we have to, and then going to create offset. Oh, first of all, we need to parent or connect, I'm not sure yet. Driver joints to bind joints. So again, as I was saying, this is just listing the actions that we need in order to create the system from the data that we have. So provided that we have the name of these pointers or locators, something like that. Sorry guys, my baby just woke up. I lost the focus. Poor baby. All right. So I'll try to speak a little low here because of baby. So, all right, I have to make a break quickly. Boom. And we're back. For everyone that was following, guess everyone is out already. Baby woke up and it's a shame she was crying so much. Anyways, it happens. Family life, my friends. I've been like this all along. So let's continue. Alright, so we're stopped on creating the offset groups for the driver joints. It's already parented. So we've made the connection. Groups for create follicles, create start follicle, create end follicle. So yeah, you're following this right now, you don't know what's in my mind exactly, so it's hard for you to have I'm trying to do this exactly for like I'm just putting it down first and then we're gonna go into that. So yeah, so right now, so the follicles is they're gonna be created on the surface. So after we have used the positions of these pointers here to create the curve, and then we loft we're gonna loft these two curves here and create a surface, and then we're going to bind the surface to these joints, and these joints are going to be driven by another set of joints that are then going to be controlled by three controllers. Okay. Cable was destroyed. I can only listen on one freaking side. It's awful. All right, so yeah, the controllers are going to be placed on the follicles, right? All right, so create controls on follicles, the parent, then constrain controls. Then we're going to connect controls. So this is going to be made in three: constraint, connect, mid control, and then connect start control to start offset group, connect end control to end offset group. So you can see that the same writing the actual code, I was doing the same thing. So declaring list for objects, creating groups, duplicate and build cursor to become system driver. This is something that I took off. Anyways, create control joint for CV position. This was all written previous, and then right, so this. So I'm gonna go on the simplest way possible here. Then if there's a way that I can further automate it, I'm gonna do. But for now, yeah. And then what I'm going to return. Let me write down what I'm going to return here. So I'm going to return. I need the bind joint, and then the drive joints, the joints, and the controls, surface, need to the groups. So group and at the end, right? So this information is likely going to be returned in order to create the system. Now we're going to start redoing it. Let's position. Position list. So first I'm going to query the information that I need. So I'm going to get these positions. I might, I'm going to start writing. It's just a very sketchy way of doing it, in the sense of just trying to do it, and if it doesn't work, or like if I not in the most effective way, just go back and do it in another way. Simple like that. Oh, it could not shake, right? Not shaky. Okay, so let's go for Xform. Will query. The way you write an Xform is then you get Xform, the thing you want to query, and then you do query SQ equals true or 1. I usually use 1, but for the sake of readability, I'm going to use 2 here. The query translate true as well, and that should give you the translation. I'm going to use it as word space, and okay, so yeah, I'm just thinking how I'm going to do it. So the next thing, do I need to do that? I'm not sure, because I guess I can just create everything I need there. So I'm going to do bind joint. Bind joint list, then I put plural. This is driver joint list. So with that, I will do driver or bind joint. And I'm going to create a joint, so joint, right? So the bind joint is creating a new bind joint. Also another thing that I'll so I gotta figure out where am I gonna take the name out of. Okay. Let's just keep going for now. Sure what's gonna be. So I'm gonna do like point GNT. Maybe bind. The importance of naming this like bind joints or B and D joints. For now, I'm just gonna call it the same name as the pointer, but with bind joints. But this is not gonna be like that for sure. And then I'm gonna bind joint list, append bind joint. This could be also be done like appending this information on a dictionary. Right now I'm just doing this like in a rough way, then start optimizing it, just putting the ideas down and seeing how we're going to structure this system. So same thing is going to go for the driver. And then I'm just going to append that to this function. With that, it's going to query the positions, and it's going to another one for to drive the system, and also we're going to position this in place. Join T equals position. So we already know the position based on the things that we queried before. Word space is true, so we want to place that based on word space. Our bind joint should be created and in place, both bind joint and driver joint. Both of them renamed. So the driver joint then should be inside of an offset group. I think that before I move it into position, I'm going to already create a group. Driver group. C.group. So when created, the joint's being created on world 0. So I'm just going to like its own name. Plus grp. That's that simple. All right, so if you're coming right now, we're working on, oh, I forgot to change the title. Damn, sorry about that. Change it right now. Here we're working on the neck module script. It's not the mod module, come on. That's it. Bye. Yeah, another magic word here first. Okay, so then instead of placing the joint itself, we place the offset group. What's broken here? Okay, so this is this. So then we have these two guys now. Yeah, so again, this is not nearly as exciting as watching animation being animated, but it's part of the process, and it has to be done right now. Right, so I'm going to create this offset group specifically for this guy. So I'm MC.group. Then I'm going to group the first joint. It's going to be private joint list 0. Gotta figure out a name for it. Just gonna leave it blank for now. So let's call it start, or even better, C1. But if you're not understanding much, I'm sorry. It's hard to create a content that is self-explanatory at this point. Just need to get this done. So here you're gonna get the last joint that was created, and the name's gonna be whatever. Okay, so we have it now. Now draw this curve. So MC, so loft base curve, MC dot curve. Okay, so this is making my life slightly hard now. It's just B, but I'm going to type point all across. And D for 3, right? So D is the degrees. What is the name? So let's get degree plus 3. The loft curve. I think then we're going to make identity. We have like a construction history here. Yeah, definitely on word space. I'm not sure if we need to Dell history. Delete loft construction history. 2. Then I need 2 duplicates of this curve. So I'm gonna call it X01. I call this curve loft start curve. Duplicate. Loft base curve. Our name for this. And curve. And that should be okay. About 1 and 1 would be not necessary, but this one's fine. It's going to be on the positive side, so T by Z, so say T0, T1, 0, 0. It wants me to just space it like this. It's going to be word space equals true. And get, so these curves are now offsetted. Again, if you're stopping by right now, this is the information about some pointers or locators or however you want to call it. So now we have already in place the two curves. We have them offset. We already gave them the offset, and now we'll be able to loft them. Now, how do we loft them? That's what we're going to find out. So we have these two curves. I'm going to delete the history just in case. Then I'm going to apply the loft. That should be this one guy here. I don't want quads, or I don't want polygons whatsoever. In this case, I want a NURBS curve. Linear, cubic, uniform, chord length. Let's see what it gives us. So this one's definitely a bit. It's definitely not that. Yeah, that's not what we want. So what we want though, and this is a good point, is these curves are definitely, oh, they shouldn't be that low. So what am I missing here? Chord length. Because I'm trying to find out. Oh, I know it. It actually doesn't really matter how many points do I have here. What I'm gonna do here is just rebuild this correctly. Like I'm thinking it's gonna be 5 the number. How it goes? Cubic, apply. 1, 2, 3, 4, 5. Rebuild again. Now 6. 1, 2, 3, 4, 5, 6, 7. Perfect. So now if we rebuild this one here too, so it's 6. We gotta take note of what the system did here. That's why you always keep the console here, console there. So right on the point that we create the curves, I should be able to already rebuild it. So MC though, rebuild. So base curve. So this is, I am rebuilding what the system has speeded. Should give us exactly the same thing that we got there. It's a pretty annoying process, right? So 0, 1. Okay, so this should rebuild our curve, although I'm pretty sure most of the stuff there is even useless. But now we have the curve with the amount of CVs that we actually need. And we can delete the 3 again and give it a lofted now. Yeah, so that's way better, right? That's more size. Has the exact number of spams that we're looking for. And let's check the command for the loft. Pretty simple. But then this is going to be a loft start curve, loft end curve, construction history 1. So usually most of the stuff is not even necessary. This is like a bunch of this stuff is already system standard, but stuff that you might be able to clean up later on. But for sure, if you just copy it, it might work. Sometimes it doesn't. You gotta go check out why. But that's the thing of like finding bugs at the end. Like you're gonna start to run the script and it's going to crash in 300 ways. And every time you fix a bug, you get closer and closer to a working Alright, so we should clear the history. So, loft surface. I don't want the construction history on this one, so I think I don't even need it to clear because I can define here right away if I want the construction history and I don't want it, so declare. Just call it as false on the flag there. So now check here. Yeah, that's the command here. I need to bind the surface to this joint, the bind joints. So then mc dot skin cluster. That's going to be the and this should give us the skin cluster back. Is that it? Maya Python skin cluster. This should return us the skin cluster. Strings skin cluster node name. Yeah, that's good enough. So skin. So surface skin cluster. We'll call it skin cluster. At least it keeps your code very clean. Okay, so we're done with the big part of it already. Joint provided here. We're gonna go and we're gonna get the position, then we're going to append it into the list, the position into the list, then create the bind joints, which is the ones that are going to be binded into the surface, and then so create the joints. We're gonna place them on the locator position and then append their names into the bind joint list. Create the joints for each one of the pointer or the driver joints. This is the joints that are going to be driving the bind joints. Then we're going to create the joint, put a group on top of it, and position the group on the position of the pointer. This is the same as the other one. And then append it to the list. So why this is being done is going to be explained later on as the system is in place. And then we're going to create the offset groups for C1 and C7. We're going to be able to see this in action, so it's going to be easier to visualize. So using the curve, let me take this degree out of the equation here, or at least out of the beginning. At the end here. So then we're creating the curve. So the curve is going to be used to loft the surface, and then I have here false. I'm not gonna save the history. This should be false, and then we should. I don't think we even need the delete history here, but anyways, I'm gonna duplicate the script 2 times, and then offset their positions by 1 and -1. And then loft the scripts to create this. So basically get the curve that's going to be created on the center, offset it by -1 to get behind and 1 to get in the front, and then we're going to use that to create the loft here. That's going to give us a surface. The surface is then going to bind it into the joint. Suppose this is going to be there's a ribbon, kind of a ribbon system for this. So yeah, times it 134. I have 1 hour already. I might be leaving in a few minutes, so just get on with this idea. Not really have the surface in play, or even the skin cluster. So I'm saying here, parent driver joint to bind joints. I think we can even do it right here. Could even do it right here. In the same loop that we are creating the joints, I will already just parent constrain them. Then I'm gonna add the. I'm gonna parent constrain always first the master and then the slave. So it's the driver joint MO, which stands for maintain offset, which that's gonna be true. Create offset joints. That groups are dry. I think that's there already. So this action is already done. So now we have to also have to import my utilities here. So import TP. Then I'm going to create a follicle here. So follicle. So need FOS. I'm not going to be using any contractions or anything. So then TPU dot follicle to even better. Follicle. Then I'm going to go with view value. That's going to be 0.5. And the V value, that's going to be 0. And then the name is going to be, I still don't know. It'll be me. One. What I could do then is for FOC and get follicle, start follicle. Control. Build control, yeah, build control. That's going to be control type. Give it a circle. So this is all functions that I have on my utilities. So if I have, so this is my utilities. If I go into build control, for instance, so this is the function, and it's okay, so it's gonna build the control. It's not even the right amount of things. I just need the variable for now. Position, FOC, position. bmc.xform FOC translate equals true. This action once for each of the follicles created. Form control. Let's see what it's. The control group that we need. One. Where this is being used at this point. Yeah, a few times on the auto map. Okay, so this is positioned now, so I want to position it on node space as well. And now we want to parent. Cool, almost there. All right, so if you stayed this far, thank you so much. I'm going to call it the day. It's pretty late right now. Yes, there's some people on YouTube and some people on Facebook. Highly appreciate it. It's gonna be a drop in the bucket process every time, just a little bit the time I have for developing it. And I skipped the automation part on the beginning just so that we can get some results and get excited about the reliable way, right? We're going to start from the neck in a simple way, just this ribbon with control for all of them, one for the start, other for the end, and that should give us the neck module. Later on, we're going to add sternocleidomastoides and there's stuff from a bit at a time. Nonetheless, once again, thank you so much, and you guys have a good night.